Welcome back to another project series. In this project, I made a web app IDS lab. So I built a payroll website. It's just a very simple web application. And then I have my intrusion detection system that monitors the payroll website over the same network. And then I have my host machine, which is the attacker in this case. And basically what I wanted to find out was how do attackers hack into web applications, how to minimize and how to proactively stop this from happening. So learning good defensive measures and building websites, and then intrusion detection systems. So if an attacker somehow tries to get in or does get in, how is that alerted and how is that system maintained and how is it able to basically send those logs over to your character. So before we even start anything, we're just going to kind of go over what this video is going to outline, just so you guys kind of have an idea what to watch for in this project demonstration. So first, what we're going to cover obviously the web app. So we're going to go through and discuss the vulnerabilities that were intentionally implemented within the web application. Then we're going to go over to how to minimize those vulnerabilities. So different proactive measures that are going to be taken away or that we put in place to help build up this web application's defensive side. And then we're going to cover how the logs are being sent over and how they're being generated. So both system logs and traffic logs. So how those are going to be working. And then we are going to be talking about how we're going to forward those logs. So sure, we generate them, but then how we're going to send them over to the other VM. Because obviously they're two different computers and they have no actual direct line of communication between the two. So how are we doing any log forwarding or anything like that? And then finally, or not finally, but we're going to cover the IDS. So basically the idea behind it, what are we trying to look for, certain patterns, the way it works, stuff like that. And then finally, we're going to have the demo. So I'll go through and kind of show you guys everything. I'll stop at each point and show you what we've covered up to that point. But obviously, the demo will cover the final demonstration, covering the vulnerabilities being exploited. And obviously, this is a safe, controlled lab environment, so it's okay to do this. So a couple vulnerabilities that we're going to cover and how they're basically executed within the code is first we can go over the password not being stored correctly in the database, as well as the SQL injection, which are kind of like the main two larger issues that I wanted to cover. So we're going to go over those right now. So we have the vulnerability. Currently it's logged out. It's commented out, but this is basically the verification for the password. So when we're being fed the password, when the user creates either a new account or updates their password, it's going to verify the password's eligibility to be obviously considered to be a password. So by removing this, what we're doing is we're basically allowing the password to be checked one time before accessing the database, and then obviously searching for the correct user. So if we go into the user where this is done here, so when a user is created, currently we're not hashing the password. So what this is doing is basically just putting the plain password, which is whatever the user put in, against the user's password. So what this is going to do is just going to check the database, making sure that the passwords line up word for word. But this obviously wouldn't really work that well, limiting that the user information is all stored in one database, making it so when the user does do SQL injection and not verify their password before it's entered into the form, it is then able to actually pull the user information from the database or apply different user access. So if you logged in using, if you select a login information from the admin command, even though you don't know the admin information, well, then you're able to actually get into the admin account and access all user information. So we try to avoid that here. But obviously, to just see the vulnerability in action, we can see that the password verification is not being done correctly. So I want to cover the schema layout on the back end. Currently, I'm using MySQL for the database storage, and my database is laid out pretty straightforward. So it uses a multi-tenant database. So let's just say I were to have multiple users using my payroll application. Let's say I have people from Meta or I have people from Amazon. Those basically act on one database, making it so that obviously if someone gets access to the database, they're able to see all user information. This is obviously a vulnerability kept in mind, but it's something that I just wanted to mention, including in the video. So moving on to the website, actually we're going to cover one more thing. We're going to cover the logs. So in this website, you're obviously going to see a lot of like console outputs. Obviously, this is debugging, but the one thing that I wanted to use for sending the logs over was making a nice like JSON file, right? Because obviously, this is going to make it so much easier to read the file into the for analysis. So by basically using Logger, which is something that I learned from my previous employer, shout out to them. But yeah, by using Logger, you're actually able to make these JSON files very nice. Basically, putting one object or one request on each line, making parsing so much easier for the IDS. But basically, what we're doing is we're applying Logger. So any console error, any console output, anything that user interacts with, any database interaction is all being logged and timestamped, and the request of what the message was. So in this case, we are going to be logging error updating the employee. So let's just say the user or the senior accessing all the employee information is trying to do an update to the employee. And obviously, if there is an issue with doing that, whether it be maybe the name is too many characters, the salary doesn't include integers, or any of stuff like that, it is obviously going to throw this issue, and then that's going to be logged and sent to the full system JSON file. The other thing I would like to mention is how these files are being logged. Like, what are we going to be doing, and how are they like leveled in priority? So different levels of logs are evident here. So we have a couple different options. So the big thing I wanted to focus on is I didn't want to have too many log options. So having, I don't know, user interaction logs, very specific logs for very specific use cases. I wanted to have more generalized systems. So including these 5 different options here, it just made it a little bit easier for classification. So I have debug logs, informational logs. So maybe if it's a user accessing certain information, a debug log could be something that obviously I'm only looking at, but that's just kind of besides the point. We have warrant logs, error logs, fatal logs, and that obviously goes up in priority. So when I check on the IDS for certain logs being sent for the traffic, or sorry, for the system, we look at the classification here. And then that's able to determine what the level of severity is for the issue at hand. So another thing I wanted to kind of show you guys is how the DB is kind of set up. So by creating this quick database export system, I'm able to kind of see the database layout and see how it's organized. So we can see here we have all the user tables. So these are all the users separate, basically like the seniors of individual websites. So this could be obviously the test, but this is like the Amazon. This is going to be like the Dayforce, but just whatever, just like test employees, the seniors that are basically manage all the employees. And then you have the admin account. So there's obviously different tokens or different things associated with each account. You have your account ID, so it's a unique identifier associated with every account. We have our email, password, our role. So depending on if it's an admin or a normal user, it's going to obviously be changed depending on that. And then we have the timestamped, obviously when it's created and when it's updated. So if a user makes any changes to their account, whether it be their password, their email, or even the account's the role status, so if the user to admin, it's going to be updated and tracked. For the employees, the only way we actually track the employees who they're created by is matching up the IDs, which they're created by. So this is created by ID 1. So all the Amazon employees are managed by this ID, and all the Dayforce employees are managed by this ID over here, which is 3. But you can see here that all the passwords are stored in plain text in the database, something that you should be very serious about and taken into consideration, that these passwords are not being hashed or stored separately. So that's creating a lot of conflict when a user tries to access the database under a different user's account. So these are how the logs are being sent over on the system side. So every system log is being tracked, and it's going to be sent over through something very similar. So these were the old logs I had. Something that stood out to me the most was they weren't very informative. Obviously, it has a timestamp, it has the level of the issue, it has the event type, so whether it be an application log, a debug log, a system log, something like that. We have the message, so depending on what the output message was of the request, it's being tracked and being stored over here. And then we have the error. So if something went wrong with the log itself, that would be displayed in the error message, but obviously we don't have an error. But in the final output of the logs that we actually send over to the IDS, looks something a little bit like this. So these are the system logs being sent over. So a little more information controlled in these logs kind of just gave a better understanding and a better breakdown for analysis. So obviously we have the error, we have the event type, we have the level of the log, we have the log type, so if it's a system or a traffic log. We have the message, so incoming request, request completed. We have the GWT token authentication. We have if you fetch all the employees from the database. We have the finding all employees, and then we have like incoming requests, and then we have certain data log requests as well. And then we have successful, like user login attempts. We have the source where it's coming from, so it's the web app. We have the host, which is the web app VM, and we have the source type, so it's vector. So we're going to cover over log forwarding in the next step, but in this case, you can see that we use vector for the log forwarding, and we have a timestamp, and we have another timestamp variable. So this is the milliseconds tracked, and these are just the regular seconds. So I wanted to include both, one for debugging purposes and the other for analysis. I wanted to line up the system logs with the traffic logs, so when they are being parsed in the IDS, they kind of have a resemblance, so they can kind of be matched up a physical way, as opposed to having these two random logs being queued, and we'll talk about that a little bit later. So now we kind of have the two VMs set up. You guys can kind of see the layout of the two VMs, what we kind of have setting up, and then we're kind of gonna go through everything, and just so you can kind of show you guys all the different configurations and everything for the vector file. So for log forwarding, we use vector. I originally used FluentBit, but I had issues with sending the two logs over in one config file. So by using vector, I kind of eliminated that. Basically just made it a little bit easier and kind of saved a headache. But essentially you can use the same thing. You can use vector or you can use FluentBit for the log forwarding. So for this, I kind of had to create my own config file, obviously because when I'm sending over, I'm going to be combining two logs. I'm going to have traffic logs and I'm going to have system logs. But for this, I'm going to be basically forwarding logs connecting over the same network. I'll show you guys how I line that up after. But yeah, you can see the vector sending configuration file here, and then I'll pull up on the receiver side. So this is the IDS VM, and we can see this YAML file here. Sorry. Yep. So we have our sources, so it's where it's going to be coming from. So we have our our raw system files. We have our directory, and then we have our data directory where we keep our for the encoding. However, what I wanted to mention here is that these use direct directories. So in the case that you do want to replicate this on your own machine, your local machine, make sure that you change all the directories with the configuration files, the IDS, the VM, basically anywhere where there's logs being forwarded. That's definitely something to be taken into consideration. We have obviously our traffic logs. We're going to go over how we capture those after this segment. But yeah, they are being sent to a very similar location. So we have our packet capture library, and then we have our Windows IBS. We then transform the files. So we want to basically parse them and basically make them so they're very nice and readable when they're being sent over. It's just like a normalization step for the logs. And then what we're sending to, so we're sending over the same network. So it's going to use this IP address. They're being sent over a tunneled VPN. So these IP addresses don't really mean anything for like you or me. But it's just like a direct path where you can actually send the logs over the same network. Sorry, over the same tunnel network, like they would do in a normal real life scenario. But yeah, so what we do is we send over two different ports because obviously we are sending two different types of logs, so we don't want to be clogging one port. So yeah, we send over the system logs over the port 24224, and then we send the traffic logs over the port 24225. So very similar. And then we are going to capture, so we're capturing from any IP address, and then we're looking for anything coming from this port. So these are going to be our system files. Then we have our traffic files being sent from or receiving from any address, but only from this port. So we are looking for the same port, and then obviously when they line up, they are able to see each other's files. And then where are we saving these? Well, we're saving these as JSON line files. So they're single object line files. I'm going to show you the format after, but it's very similar to what I showed you in the previous slide or the previous section in the web app. But yeah, pretty much they are single object JSON files, and that just obviously makes it easier for parsing. So now we're going to cover a little in depth into what I've been doing with the packet capturing library, or the packet capturing application, sorry. How I'm capturing the certain traffic on the website, and what I'm looking for. So if we see here, obviously we are going to be studying, or sorry, we're looking for certain areas and certain issues that are going on through the traffic. So first thing that we're obviously logging is the timestamp. So we are logging all the information on a single line, and that's obviously going to be done through this. The next thing we're doing is the flags being sent over. So each request in the TCP handshake. So whether it be like a synchronization, an acknowledge message, and stuff like this is going to be done through the TCP flags, and basically converting those to strings, so they're obviously being able to send over to the JSON. We then obviously log all the traffic. So we first open the traffic file, then we are going to start logging to it, and this does on continuous logging. So the way this works is, let's just say you were running the IDS or the packet capturing application before, you stopped it and continued to operate it, it would continue printing to the same line, and obviously it would rotate day to day. So if you were running it overnight, it then rotates the date and able to basically continue printing the proper logs for the proper dates. And then we are basically parsing the TCP packet. So we're capturing the TCP packet, and we're applying our parsing and basically levelizing it and extracting what we're basically taking out of it. So we capture the protocol, and we look for the proper flags. We then pull the flags, and then we convert it and store the payload. We also capture the length of the payload. So if a user does a lot of requests to a single form in the web app, we obviously capture those the length of each request, and then it gets flagged. And obviously, after a certain amount of flags, the user that operates the IDS is alerted, and then obviously can move from there. We have how the logs are stored. So they currently look something like this. When they're being sent over to the IDS for analysis, we have our captured length. So it's the length of the total captured request. It is 66 bytes. So these are all captured in bytes. These just make it a little bit easier for the analysis in the IDS, because the capture length of the system logs is being sent over as well in bytes. So it just makes it very easy to distinguish between both of them. We then have our destination IP address. So it's obviously on the same network, Tunnel VPN. So the only thing that really changes is the end of IP address right here. We then have the destination port. So whether it's being sent from the local address or the new address of the different VM, which is the IDS VM. We then have the length of the capture packet. The length. This is another thing for debugging. I included this as well in the payload length. It just makes it a little bit easier for me when I go through and basically distinguish between what's what. We obviously have the log type, so what it is traffic. We have the payload length, so obviously depending on what the payload is, we then store the payload in bytes, and you can see it out here. We will obviously go into detail about what a large payload is and how to distinguish it from a smaller payload, and then what to do with the length of the actual request. We then have the source of the app. It's the web app IDS. So it's being sent from the web app VM. We have the source host, which is the web app VM. And then we have the source type, which is the vector. So that's obviously from what's forwarding the logs over. We have the source IP. So in this case, it's the host VM. So whatever hosting the web application. We have the source port. So the port that's on the web app. We have the flags associated with each request. So whether it be a synchronization, an acknowledge, a synchronization, or just acknowledge. We then obviously capture those flags, and then we include it in each request. We have our timestamp. We have our timestamp in seconds. So this is another thing we wanted to include with the milliseconds as well, was being able to mimic or basically align the logs similarly with how we did the system logs. Just makes analysis a little bit easier. So now we are going to be analyzing what we did with the IDS. So for the IDS, it obviously runs on a separate VM. being forwarded those logs. So I can just show you where the logs are stored. So we have our system logs and our traffic logs, and then obviously there are our object line JSONs. So we can go in here and see each object on each line. We can see what the request type is, where it's being sent from, the level of the request, and what the message is, stuff like that. So that's the system logs. And then we obviously have the traffic logs, and they'll be synced up in the VM or the IDS, but we'll show you guys that in a bit. So for the IDS, I didn't want to cover every single possible outcome that could be basically accomplished monitoring over a web app, because obviously that's very time consuming. And I kind of wanted to just cover the main top 5 of the top 10 OWASP basically vulnerabilities. So we can kind of go over what like the design focus was, the rules in place, how to distinguish a like priority of each message. We can go over the queues, so how it's each message is queued being sent to the IDS, logging the basically parsing the logs, and then yeah, and then we can go from there. So we can go for this first area right here. So I use the hlowman parsing for the JSON. It's a very nice library. It basically just makes parsing the JSON lines much easier because it eliminates having to do the basic like needy stuff as to do a normal parse of a JSON. So we can go through here and I'll show you guys what I mean. So right here, we can go through this first, parsing each JSON line. So whether it be a traffic log or a system log, each JSON line needs to be parsed. So that can be done very simply, as opposed to obviously making a longer C++ program. And this does not take away from efficiency at all. It just applies different aspects of C++ to the JSON library, so it just makes it a little bit easier. So yeah, so that was kind of the main library behind the JSON file. And then obviously we include some of the other basically simple Windows libraries, or sorry, the C++ libraries. So we're going to use the queue, and then input, output, and then string and stuff like that. So we store our structs, or we store each log as a struct, whether it be a system log or a traffic log, and then each struct is associated with the data that's storing. So these are lined up with the logs that are being sent over. So we have our event type, our level for the system, message log type, source app, source host, timestamp, the system call, and then the data. So if it's a admin logout or a user logout and that type of command. We then have our traffic event. So we have our capture length, payload length. We have our source and destination IP. We have the source and destination port, our flags from the TCP handshake. And then we have our timestamp, our log type, and our source here. So we have the source application, the source host. We then have the state. So what is the state that is basically allowed for the rules to basically be applied from the IDS? So a couple of things that can be stored and added future could be increasing the different allowed user login attempts and being tracked on separate users. So right now I just do IP field attempts. So if a user logs in from two different accounts on the single IP, it would be classified as one IP login attempt. However, in the future, this can be implemented with separate users. So if a user logs in under UID 1 and then UID 2, it would track obviously both those users' login attempts. But yeah, we track IP field attempts, IP admin denials. So if a user is either trying to register as an admin or log in as an admin, those both classify as failed attempts. But this one would be IP admin denial. We have admin actions. So updating user database, updating employee information, obviously changing role access and stuff like that. We have our IP large payload count. So we have the payload length. It cannot be anything over 1,000 bytes. So 1,000 bytes was something that I wanted to basically test out here. It can obviously be changed to something a little more less forgiving. But in the case of 1,000 bytes, it only tracks when a user either registered an account with admin, or a user accesses certain database credentials or updates certain database credentials with a large payload. So this could be updating employee information, because that's obviously going to be sending the payload over 1,000 bytes, just because a lot of the fields that they fill out require a lot of information and stuff like that. We then obviously track the flags. Yeah, and then it's linked to each IP address because we are doing a map. So we're going to map the request of the IP address with the flag count, and we associate each flag count with a numerical value, which just makes it easier for understanding. Then we have our thresholds. So we have our failed login window, which is 300 milliseconds. And what that is going to do is if a user fails to log in multiple times with less than 300 milliseconds of duration, then it's obviously going to add a failed login attempt in the threshold. And that just stops the spam login attempting. So if a user sets up maybe like a bot or a certain script to mass apply to these certain fields, it would obviously be flagged. We then have our alert struct. So this keeps the priority in the message of the actual message itself. So a priority in this case right now, we only have 3 levels, 1 being low, 2 being medium, 3 being high. We'll talk a little bit more about this alert later, but yeah, currently we only have the priority of each alert, and then we have the message of each alert. And then something like this can be improvised or can be changed in the future by adding the alert being sent, I don't know, via email to your cybersecurity consultant or anyone that's being actually in charge of your security system. But in this case, we were just outputting to the console terminal just as a nice, quick, easy way of actually seeing the logs being displayed live. We then have our IDS rules. So a couple simple rules we can cover, obviously, are the admin denial threshold. So how many admin login attempts that are actually allowed in the same time. We have large payload threshold, so that's 3 large payloads before it actually gets flagged. And then obviously these numbers can be changed and randomized. So maybe if you're doing, I don't know, if you're doing consulting for a company, you can randomize these values between, I don't know, we have value of 1 or 4 or 5 or something, and then that could rotate per day to day. So maybe some days you can basically just change it around, obviously if you need different security or if you just wanted to test out different approaches. We have the synchronization flood threshold, which is 100 synchronization attempts before a acknowledgement request is being sent. So all this is doing is basically just catching if a user is sending a flood of synchronization threshold, synchronization flood attacks or requests to the form or the user application before being caught. We have the handshake imbalance threshold. So this is between any handshake imbalance. So maybe if it's a synchronization at acknowledge or a acknowledge synchronization, that can be a max of 25 differences between each synchronization attack or flag between obviously a message is being sent out. We have the admin whitelist IP address. So something like this would be changed to whatever your host machine is that operates under the admin perms. So this could be either a list of admin IP waitlisted IPs or just a single IP admin if you only have one admin looking over all the user information. This is all of the users, so this is a admin, obviously not a user. And then we have contains any, and these are get data. These are just helpers when we're looking for the logs. So contains any would use for our message. So if we look for specific messages, we can use this contains method, and we can look for invalid passwords, invalid credentials. And this just helps combine the certain messages and certain flags that can be associated with multiple attempts. So this would be the IP failed attempts, and what we're doing is we're looking for auth failures. So any invalid password, invalid credentials, failed login attempts, auth login failed, any attempts like that will be classified as an IP failed attempt, and it would just be incremented through the source IP. So they're all being tracked under the source IP. So whether it be multiple users, it can obviously track that. And then we obviously check the actual condition itself. So if the failed IP attempts from a source IP, so this could be from any user, and if it's greater than the failed login threshold, remember the failed login threshold was 3. So if it's greater than 3 failed attempts under the same IP address, well then obviously it's going to send these alerts to your IDS or your admin in this case. Payload stuffing, so data is too long for a column. This could be for trying to max out a payload, basically over send a request to the server. And What this does is it just checks to make sure that, I don't know, for an example, could this be when creating a new employee? In the employee message, when you're either changing the name of the employee or upgrading the salary of an employee, it basically just limits the amount of characters applied to a column. And these aren't just like reasonable amounts. I would say that these are definitely incremented for this lab in general. It is very large, but it just makes it stay under that 1,000 payload threshold, just so we can kind of max out the current attempts that we do get, and that we can actually verify them if the payload is over 1,000 bytes. We then do access control and admin actions. So if it doesn't have admin role, if they're doing forbidden actions, or they get access denied in certain actions. So this is changing employee information, basically deleting employees from record. That all can't be done through a normal user, so you have to get admin perms to do that. But yeah, obviously that would flag an issue, and that would add to the admin denial threshold. Then we look for the admin actions. So if you either create employee, update employee, delete employee, anything that deals with database resolved actions, that is going to be put as a if as long as the source IP is not aligned with the admin IP waitlist, because let's just say a user does get logged into a admin account, but obviously they're from a different IP. So by making this source IP not equal to this admin IP waitlist, we're able to still maximize the current reach that we can get with the IDS. So if a user logs in under an admin account that is not the admin IP whitelist, or is not in the admin IP whitelist, well then obviously that's going to be flagged, whether the user even has admin perms. It's just another security measure that can be put in place for database CRUD operations. We have payload anomalies, so this checks if the payload is over the 1,000 pre-specified amount. This was more of a debug output here, but yeah, it's basically just checking if the payload threshold, or the state that the payload threshold was given, is over the current limit. Well, then obviously it's going to flag and send the message to the alert system. So you can see here that we have 3 different outputs here in the return message. I know before in the alert we only had 2, which was the message and the priority, but I wanted to include the timestamp in the message, just so it made the IDS a little bit more understandable, and when certain attacks happened and when they got caught. We then check for the flags. So this just increments the flags when they see the flags. So when it's parsing through each line of the JSON, it's going to track the acknowledgement requests and the synchronization requests and the other flags that are associated with TCP requests. Another tracking method. We then check for a SYN flood. So obviously we counted that synchronization. We check if it's over that threshold. And then we check the handshake and balance threshold, so another one of those threshold maximization methods. And we just check if the difference between all the different handshakes is less than that threshold right there. We then send the alert. So this is what's going to be outputting to the terminal, but in this case, this could be sending to an email to your security SOC analyst, or any via email, text message, stuff like that. But in this case, we're just outputting to the terminal. Yeah, a little more simpler, but it just kind of gives a live representation of what the application could do. But yeah, what we're doing is basically just outputting the message. So we have the timestamp, we have the priority level, and associated with the priority parameter that was popped in here. So we have the priority. We check the priority, we obviously line it up correctly, and then we timestamp it, and then we send the alert message. So whether the alert message was, large payload anomaly, we have the IP address, and we have the different handshakes and synchronization requests that are responsible for certain messages that are associated with each alert. We then have the process of queuing the logs. So in this case, we take in 2 different logs. We take in the traffic logs and the system logs. And what we do is we actually process them separately and then combine them in a synchronization step. So when we normalize the logs, which was done above previously, we then separate each log into its different queue, and then we queue it for analysis. So all we're doing here is we're basically just on each system event, we're taking each log and we're popping it from the queue. So each time a log is being sent or is being read in, is being added to the queue. So each queue, or each position in the queue, is just a log, like a single object log. And then all we're doing is we're basically just popping it from the queue. And then we're sending it on to the classification. So if it's either a system event, it's being sent to system event. So for a system event, we obviously do the system analysis. Or if it's a traffic event, we do the traffic analysis here. Perfect, like that. Yep, and it's going to pop it perfect. And then, yeah, obviously this is for the parsing the JSON lines, so it's going to parse each line, basically just making it readable for when we send it to the queue. It's going to try to read a line, so this is a way of updating for new logs. So this works when the IDS is not being fed any new logs. It's basically just going to wait to the end of the file, so it doesn't just end and crash the program. These convert the strings to integers, so certain fields like the synchronization methods, the TCP flags are being classified as integers, make it a little bit easier for analysis. But yeah, that's just a method that converts the string to integer there. We normalize the system JSON logs, and we normalize the traffic logs. So obviously we are talking about that get string field and the get in field. So the payload length is obviously going to be integer. So we save that as an integer. And then we have the string as the certain IP addresses and flags and certain messages as well. But for the system logs, it's a little more easier because everything is considered a string. So there's no need for normalization here. All we are doing is basically just formatting the logs, basically preparing them for being sent to the queue. Obviously we initialize the queue. And then we have the NQ log. So depending if it's traffic log or a system log, we basically align it to its specific path, and then we push it to the queue for analysis. And then obviously we have the main loop, so what's being looped through. We have each file, so where the files are stored on the IDS VM. We then have obviously our error checks, check if the file can be opened. We seek to the end of the file. So whenever the program starts, the IDS starts, it's going to go to the end of the JSON file, just so it doesn't re-go over other old processed logs. It's just kind of a big backup, so it doesn't basically just waste a lot of time doing unnecessary steps. And then we have our read lines, so it's going to parse, and then it's going to enqueue the parse JSON log into the queue, and does that for both the system and the traffic file. And then we have obviously the state checker, so it's going to process the queue. It's going to take both the system and traffic queue, and it's going to apply the IDS rule and the IDS state, so as we defined above, and it's going to go through and analyze each log and determine whether it's a flag or not. And then obviously, depending on the priority, it'll notify the user or the admin operating the IDS. So finally, for the last part, we're going to go over the demonstration here. I'll kind of cover the process of doing everything in the pipeline, and we can go through and we can see the results. So the first thing we're going to do is start the receiver for the logs being sent over. So we're going to just start that vector file there, and then we're going to start the sender. So once we start the sender and we start the receiver, they start talking and they're like, "Yo, like we can do this," and then we're going to start the server. So because we use Express, we can just start this using npm. We start the server, and it's running locally. Sorry, not locally. It's running on the VM machine on the port 300. So the next step is starting the packet capturing library application. So I include a lot of the debug lines on the output. This is just for testing purposes, but you can see on the output each log or each request being made on the packet capturing library, and each log request being made on the actual on the system side, like the system logs being sent through the web application. So this is the web app here. It's a pretty simple web app. It's just like a simple payroll application. I can kind of go through and show you guys how it works, the rundown, and how everything basically works or whatever. Okay, so we are going to log in under just a normal user account. So this is just going to be a nice test account. It's pretty straightforward. If we get the password correct, we log in, and then we are access to the employee dashboard. So this is where we're able to see all the different employee information associated with this user account. So if we go to view the employee records right here, we can see that we have the employee list, which is just all the created employees associated with this user. So we can see these are all the Salesforce users. Obviously, these are not actual real people, but like for this case, they are going to be our temp people. Yeah, so basically when you create a new employee, it asks for a couple different issues for the field. It takes the name, employee, position, department, annual salary. And obviously these are one of the cases where I talked about the form and limits on certain areas for the form to be filled out. But yeah, once you create an employee, you'll be added to the employee database, and then you're able to see all the employees listed here. Yeah, so that's basically just access for a normal user. They have access to the employee dashboard, and they have access to add a new employee. We can log out there. So for registering, if you want to register a new employee or a new admin, the ways you can register are sending in your email. So by adding a different email, we can use test 5 here, for example. Creating a new user, password can be whatever you want. And then these are the admin keys. So this will actually authenticate you to be an admin. Obviously, this isn't the best practice to do admin authentication because it is stored on the same, or the admin key is stored in a environmental variable. But in this case, you just kind of don't want to be doing that because it basically exposes you to SQL injection. However, for this case, we're just not going to add anything because we're just going to do normal user. But yeah, we're going to log in here. Successful. We are going to save that account. So we're then going to log in as user. And we can see we have no employees. So yeah, we can go through and just see all the employees we had, but we didn't have any, so it's fine. This is for a admin user, so I already have a pre-admin account. We see very similar login to their admin accounts, but obviously this would be whatever user your admin has. We log in. There is a extra area here for an admin. They have admin management, so you can see all the different users associated on the same database. So we have their ID, so the ID of the user. We have the email associated with that user. So we have test 1, test 2, we have our admin, we have a bunch of test emails. We have the role of all the different users. So we have the user role and we have admin role. We have when the account was created, so the little timestamp for the admin to go through and basically just visualize when the account was created. We have admin access. So this is where you're able to actually toggle admin access on for certain users and toggle it off for other users. And obviously all this is logged and being sent over through the system logs to the IDS for analysis. So a couple flags were actually rose there when I was doing the admin alerts. Because we run from a separate IP address and we only look for the local port 300, we actually alert the detected admin action from local IP. So this is a high priority alert. So normally you wouldn't see these debug messages, but in this case I'm using it just for clarity purposes. But yeah, you can see the timestamped action here. We can see the level of the alert. So this is a high priority alert because it is associated with access control issue. And then we have our message associated with that issue. So we have admin action from non-whitelisted IP address. So we see we have the local 300 or 3000, and we have the message associated with that. So we have the user has admin role. So this is associated with if a user got access to an admin account and they don't have the proper IP address associated with that, that obviously will get flagged. So another test we can do here is SQL injection quickly on the login field. And what we're doing is basically just going to log in with a random email. So we can do something that's really not associated with this at all. So we can do a bunch of numbers. So we can do like, I don't know, 239, whatever, and then at whatever.com. And all we're doing is just to get past the email field, basically just putting in a temp, whatever, throwaway email address. And then we are going to be doing SQL injection on the form. So all we're doing is just checking the email field. So it's going to do a check for the email. And then in the email, it's going to, well, obviously it's going to be selecting all the users from this email address. And then it's going to do or if 1 is equal to 1. So this is always going to be true. So it'll always just let me in under the first user's account or the latest user's account. And then for the password, we can just type whatever we want. Bunch of nonsense, whatever. And then, yeah, and then we get a login successful, so that passed. We can see that we are on a different user account, something that was actually good that it happened. So we actually proved this vulnerability to be true. But yeah, we can view the employees and look at that. We're under a Amazon employees account. And we can see the different sensitive information associated with that, the records. Rebecca Stewart's, and we have Robert Smith. demonstration. I enjoyed building this project. So enough to share it with you guys is kind of all I kind of wanted to do. As well as I'll link the GitHub repo in the description, so make sure you guys check that out if you wanted to replicate this on your own device, kind of see how it works and just kind of work through different vulnerabilities that can be exploited. And then obviously you can set it up in your own machine and test it out. Thank you.